Hello, both of you. Good evening. Yeah, I think I'll just start today's class. And yeah, so this is about week nine's lectures, and we'll just be quickly looking at the revision of whatever was covered in the lectures, and we'll solve problems and have an R demo. So okay, I'll just start. Am I recording? Yes. Okay. So yeah, in the previous week's lectures, we saw about the distributions that continuous and discrete random variables would follow. And one of the distributions we covered was normal distribution. So the normal distribution, so it would follow the distribution so this would be the formula. It will follow a distribution which is given by the formula. So f of x, the PDF, would be given by this formula here, like e power minus x minus mu by sigma square, x minus mu the whole square by sigma square. Yeah, so yeah, this was the formula for univariate normal distribution. So when you have just one random variable x, we have this formula here. But now we are looking at bivariate normal distribution. So in the previous lecture, we also saw about other multivariate distributions, which has like when you have like more than one random variable. So now we are looking at bivariate normal distribution in this case. So again, like you can see, it's an extension to this univariate normal distribution. And the probability density function of a bivariate random distribution is uh, given by this complex formula here. You don't have to remember this, but yeah, so we'll be looking further of how you can apply this. So the important parameters here are that the standard deviations, they have to be more greater than 0. And this factor over here called rho, it's always between -1 and +1. So these are some things. And also yeah, it's denoted by the formula. So earlier in univariate normal distribution, it was just like n of mu comma the variance. But here in this case, you'll have mu of x and sigma square of x and mu y sigma square y. So similarly, we also have conditional distributions. So like we saw earlier, like it was like two variables. So when you say f of y given x, the equation is in terms of y. Like you can see the mean and the standard deviation, it's all in terms of y here. But you integrate over the whole interval of x. And similarly, the other case. So f of x given y, you integrate over the whole limits of y. And yeah, you have it in terms of x. So now what happens is this first term given here, it becomes your new mean. And this is your variance. So mean is also expectation of x given y. And this is like variance of y given x and y given x. And this one would be expectation of x given y and variance of x given y. So yeah, you might have to remember these. We'll see how these are applied in some problems today. Just checking. Okay. So the other thing is covariance of x and y. So covariance of x and y is basically like covariance of x multiplied by covariance of y. And we have this rho factor here. Like whenever you have a constant, you just multiply it. And okay, we don't need this. So yeah, let's say you have, let's say x is a random variable and it's a vector. So x could be like x1, x2, x3, and so on. So like you can see, it's like this. So it would have a mean, which is also a vector, mu1, mu2, and so on. And with that given, you would also have a covariance matrix where the diagonals are the variances. So basically when I say that, let's say we have random variables x, y, and z. So this is your initial vector. So the mean of these would be mu of x, mu mu of y, and mu of z, and so on, like whatever alphabets you have. And the covariance matrix in this case, in your diagonals, you will have the variance of x, like sigma x square, and here you'll have sigma y square and sigma square of z. So in the diagonals, you'll have like covariance of x comma x and covariance of y comma y, covariance of z comma z. So yeah, in the non-diagonals off diagonal elements, you would have here what you would have sigma standard deviation of x comma like multiplied with standard deviation of y. And this would also be the same. So here sigma 2 1 is equal to sigma 1 2. So these elements would be the same. Like yeah, and here you would have sigma what is this? You'll have sigma yz. Here also you'll have sigma yz and sigma xz, and here you'll have sigma xz and sigma yz. So yeah, this is called a covariance matrix. And so the mean of this x is again, like we saw, is given by mu, and covariance is basically this. Like the variance of this, the variance of this vector of your multiple random variables would be this covariance matrix. So that's what this slide summarizes. And then further, so we have seen all this normal distribution and like Poisson distribution, geometric distribution, and all that. And now this even more distributions called sampling distributions. So now before that, let's say we have this list of random variables. So any function that we do on a random variable, like we take a mean of the random variables of RVs or variance of random variables or just a summation of all your random variables, like any operation you do on these random variables, it gives you some value, and that value is called a statistic. So now sampling of so statistic is a function of the random variable. So this is also a random variable. So when you do a mean of the random variables, that also gives a number. So that's also considered a random variable. And that is basically a statistic. So these statistics are said to be distributed so they could either follow a distribution, so they could follow any of these sampling distributions. So all these statistics follow distributions called sampling distributions. And these sampling distributions could be chi-square distribution, T distribution, or F distribution. So yeah, there could be many other distributions as well, but here we are mainly focusing on these three because you'd normally see a lot of these in statistics. So the first thing is chi-square distribution. So here, let's say let Z1, Z2, Z3 be independent and identical random variables. So each of these, they follow a normal distribution. They follow a standard normal distribution. So with that said, the sum of all these, the sum of the squares, so Z1 square plus Z2 square plus Z3 square and so on. So the sum of these will give you some value, right? Summation of Z square. So this value is said to follow a chi-square distribution. So let's say if I have three Zs. So here n is 3. So n is basically the initial number of random variables, initial number of samples that you have that follows this distribution. So that is basically termed as degrees of freedom. So you denote chi-square as chi-square n. So n is the number of samples basically. So far in all this distribution, the initial sample size didn't come into the picture. Like, yeah, how many random variables you have, like how many samples you took, that didn't matter. But here it matters because, yeah, so that's why they're basically called sampling distributions. So yeah, the PDF again here is given by this complex formula. You do not need to remember this. Yeah, you just don't need to remember this. But remember, it always follows. So x has to be greater than 0 in this, like for any distribution to be a chi-square distribution, like x has to be 0. So also these z random variables here, they followed a standard normal distribution. So when we have random variables that some x, y, z, but let's say they do not follow a standard normal distribution, they just follow a random distribution with a mu and a variance. So in this case, if you remember, like in a univariate normal distribution, we derived z by computing a given value of x minus its mean divided by its standard deviation, the whole square. So, sorry, not square. It's just x minus mu by sigma. So that gave you z. So you apply the same thing here. So when you have random variable x, y, z, whatever, you do x minus mu by its sigma, and you take a sum of their squares. You do this. So now when you do this value would also follow a chi-square distribution with n degrees of freedom, again denoted by chi-square n. So yeah, so you could, so chi-square n could follow any, like it could follow normal distribution, or it could just follow standard, it could follow any normal distribution. And the mean of a chi-square distribution is basically the number of samples that you take, which is given by n. And the variance of a chi-square distribution is 2n. These are things you might need to remember. Yeah, like you might have to apply them in problems. And also, then another characteristic of chi-square distribution is that it is not symmetric. So we saw the normal distribution is symmetric. So this area is equal to this area. Like whatever area you take, it's equal to the other side of the mean. But chi-square distribution, it's not symmetric, and it's like skewed, it's positively skewed, like it's skewed to one side. It's something like this, like the mean is here, but yeah, it's skewed. So it's not symmetric. And like we said, the random variables can only have values like 0. Like, I mean, when I say that, I mean the sum of the squares of the given random variables has to be greater than 0. And the degrees of freedom, the number of samples you take, it determines the shape of the distribution. So if you, I might have a figure here. So yeah, there's a figure. So when you have less samples, only 2 samples, you can see that distribution is like this. It's just close to the 0. You don't see like a peak. I mean, yeah, it's like, but when you increase the number of samples, you can see a peak here. You can see the curve shifting to your right. And when you have even more samples, you can see it further shifting towards the right. So yeah, this is how like the n value determines the shape of your curve. What is this? One other property is that, let's say you have 2 independent random variables, and each of these random variables, let's say m and n are random variables. So m follows a chi-square distribution with m degrees of freedom, and n follows a chi-square distribution with n degrees of freedom. So when you sum up these 2 random variables, so m plus n, they would also follow a chi-square distribution, which is equal to m plus n degrees of freedom. So the sum of these 2 random variables is chi-square m plus n distributed. And one more thing is that you remember that we have seen, like we learned something about population, uh, population variance, population mean, and sample variance and sample mean. So, like if you remember, there was something like the denominator, like you would take a sum of x minus mu whole square by n. But R, it would compute this term with a denominator of n minus 1. So n minus 1 is basically for a sample, and n is basically a population. So let's say like I want to analyze the effectiveness of a drug in a population. So it is technically, let's consider India. It's technically impossible to give the whole population. You can't give each individual in India the drug, and you can't record the observations. That is impossible. So what you can do is you could rather pick a few people. Let's say just pick random people of different age groups from every state. So that is something you call a sample. and that is easier to observe. So that's what that's what's the difference between sample and a population. So yeah, now so an important example of chi-square distributed random variable is the sample variance. So the population variance is sigma square and population mean is mu, whereas the sample mean is given by x bar and sample variance is given by s square. So the sample variance s square of an independent individual random sample x1, x2, x3 of size n, they also form a normally distributed population. So let's say let's say in the question, you have a numerical problem where you are given with this value. You have the population population variance, but you have to compute sample variance. I just have to compute the distribution for 20 people. So that is when you apply this formula here. You can apply n minus 1 s square by sigma square. So this new value, it now follows a chi-square distribution with n minus 1 degrees of freedom. So when you convert a population, so you have a population variance and mean, you convert that to a sample variance. So this new value will have a chi-square distribution with n minus 1 degrees of freedom. So yeah, it's given by this formula. So now, like we said, we just saw here, the summation of x minus x bar the whole square divided by n minus 1. So that is your s square. That's how you compute this. And yeah, now we're coming to the probabilities, the PDFs, the areas. So this is given by probability of chi-square greater than a given value, chi-square n. So this area would be equal to alpha. So earlier in normal distribution, whenever we said something like you consider a given point and the value the area up to that given point was calculated. But in chi-square distribution, let's say you take a given point, but the area after that given point is calculated in some cases. Yeah. So wait, let's just see examples to be more clear. Uh, okay, so how you compute this chi-square thing? Like for normal distribution, we saw that there are online tools, and we mentioned that you could also use a table, a normal distribution table. And similarly for chi-square and all these other distributions also, you have a table like this. This table is basically the integrals for each. So the n here is the degrees of freedom, the number of samples. It could be anything, go on. And this is your alpha value. The values given here are your alpha. So let's just take a random point here. So let's say I take 2 point, I take, I have 11 samples, n is equal to 11. And so this is my chi-square distribution. So the value given here is 2.6. So let's say this is like 0, 1, 2, 3, 4, yeah, whatever it is, right? So this value 2.6 over here. So this basically denotes that the area beyond this point. So you take a specific value and the area after that given value occupies 99.5% of the whole area of the distribution. So this is how you read the table. It's the other way around. This doesn't mean that at 0.99 you have this area. That is not how you read it. It's the other way around. So at a given point, yeah, so at a given point, the area above that is 99 percentage. And let's just draw it again. And let's just consider this value over here. Let's say 26. 26 will probably be somewhere. So 2 was here, 26 will be somewhere here. So if I take 26, the area above that is very small. Yeah, it is just, how much is this? 0.5% of this whole curve. So that's how this you use this table. So chi-square distribution was done. And the next one is t distribution. This is also one kind of sampling distribution. So you have a t distribution when you have two, sorry, you have two independent random variables x and y. So here one random variable, it follows a standard normal distribution, but the other random variable follows a chi-square distribution. So in this case, so the ratio of these two parameters, so this ratio, which is like x divided by the square root of y by n. So this value here, it follows a t distribution with n degrees of freedom, again, n samples. So yeah, this is also called central t distribution. And the PDF is given by this formula here, which you don't need to remember. So here x could be anything between minus infinity to plus infinity. What's this? Here what happens is um, mean and variance. So yeah, so when you have a random variable that follows a t distribution, so this random variable is basically x by y divided by n. So sorry, square root of y by n. So this one follows a t distribution. So the mean of this value x is 0. And the variance of this is n divided by n by 2. So you might need to remember these. And here always n has to be greater than 0. So the minimum sample size has to be 3, like greater than or equal to 3. So basically it just has to be like n should be greater than 2. And the t distribution is symmetric. Unlike a chi-square distribution, it was not symmetric, but t distribution is symmetric. And the t density has thicker tails, indicating greater variability than normal distribution. So even here, the n degrees of freedom, it determines the shape of your curve. Do I have this? Okay, let's see. For that. Okay, what does this mean? T density has thicker tails. So we know that normal distribution looks something like it looks something like this. But your T distribution would something be like flatter. So it will have thick tails. So if you look at this tail, these are thicker. So it would just be, yeah, I think this diagram would be better. So as you increase the degrees of freedom, your tails will also get thicker. Oh, sorry, I said the other way around. As your degrees of freedom increases, the tail gets thinner. So well, what happens is when you have a sample size of 30 or above 30, when n is greater than or equal to 30, your curve will follow a normal distribution. So the random variable x that follows a t distribution. So this holds only when the sample size is lesser than 30. So when n is greater than 30, it follows a normal distribution. So basically, if you look at the t distribution, the table you'll just have n degrees of freedom till 29, because after 29 up to infinity, you can calculate using the normal distribution formula. So like yeah, the same thing. Wait. So yeah, this is again the t distribution table. You have n degrees of freedom and the given area. So this is like 0.10, 10% area, 5% area, and so on. And these are the points. And even here, that sampling, like when you have like a population and sample variance, so it could be calculated using this. So like n x bar, the sample mean minus the population mean divided by s, the sample standard deviation, it follows a t-distribution with n minus 1 degrees of freedom. These are some properties that we just saw. So yeah, like we said, this is the difference between, so normal distribution, this tail is very thin, but t-distribution, the tail is thicker than normal distribution. But when you keep on increasing the degrees of freedom of a t, and eventually when it really becomes 30, your curve will look like a normal distribution curve. So the last distribution is F distribution. So this is when you have two random variables x and y. Both of these follow chi-square distribution, chi-square m and chi-square n. And the ratio like x divided by m and y divided by n, it follows a F distribution with m comma n degrees of freedom. So here you need two sample sizes, m and n. So this F distribution, it's the abbreviation for Fisher, no, Fisher distribution. So again, the PDF is given by this complex formula, and the x has to be greater than 0. It's same thing. Oh yeah, I just pasted same thing here. I think I can. Yeah, so the mean of the random variable that follows an F distribution is given by n by n minus 2. And the variance is given by this formula. And n has to be greater than 4. Because the denominator here can't be 0, right? The variance can't be 0. The variance has to be some value. So n has to be greater than 4 to satisfy that. And you might need to remember these. And also the F random variable is non-negative. So that's why, yeah, the denominator here can't be 0 and it's always positive. And the distribution here is skewed to the right. So F distribution also looks something like this. Do we have a picture? Yeah. So this is what your F distribution looks like. So with less degrees of freedom, your curve is more towards the right. The peak is more towards the left, sorry, left. And as you increase your degrees of freedom, it just keeps getting skewed to the right. And again, this is the table. So here, this is for M and this is N degrees of freedom. And you'll have the area. And the properties could also be such that if X follows an F distribution M comma N, then so 1 by X will follow F of N comma N. And so if X follows, so let's say here, this one, the mean here is 1. Mean for M, the random variable M is 1. And this follows a certain mean. If X follows such a distribution, such an F distribution, then the square root of X follows a T distribution with N degrees of freedom. And yeah, similarly, it could also hold for the same thing, which is M comma 1. So square root of X would follow T distribution with M degrees of freedom. And yeah, when you take a square, yeah, it's the same thing. So when X follows a T distribution of Tn, then X square will follow an F distribution of 1 comma n. So these are basically the inverse of each other, if you look carefully into it. Okay, so this is the last part of the week's topics. We have distribution of sample mean, convergence and probability, and weak law of large numbers. So what is this? Yeah, so like we discussed, we have population parameters, mean mu and variance sigma square. So you will not know the population parameters, like I said. Like in India, you want to know the mean age of every single person, considering every single person, that's a bit hard. You might not know that. But let's say I have a classroom with 10 students. I want to know the mean of their age. That is much easier. So that is your sample here. Sample parameters, like we said, mean is X bar and variance is a square. So we know this is not known in many cases. So for random variable x that follows a normal distribution with mu sigma square, x, so the sample mean and sample variance are independently distribution random variables such that they also follow normal distribution. So this mean will follow normal distribution with the mean mu and variance sigma square by n. You won't have just sigma square, you'll divide the variance by the whole population size. And yeah, again, the sample and population variances follow this formula. So n minus 1 s square by sigma square follows a chi-square distribution with n minus 1 degrees of freedom. Let's see how this formula can be used in problems. Like I think one of the problems, yeah, will use this formula. Okay, something. Yeah, we'll look at these in our. And yeah, the other part was convergence of random variables. So like if you remember, you increase the number of experiments, the mean and your variance of the whole experiment will converge to a certain value. So this is also similar to that. So let's say you have a mean x. No, what is this? So ideally you want your x to be converging to the mean. So let's say the mean is 10. I have different samples, 9.9, x1, 9.9, x2 could be like the mean of x1 could be 9.9, could be 8.9, x3 could be like 9.8 and all this. So ideally you would want them to be closer to 10. And how will you know if they're closer to 10? So they are closer to 10 if the difference between this mean 10 minus 9.9 it's like very less, right? So the difference between the two values has to be less. So if this difference is lesser than a certain value, which is given by epsilon, you would say that the probabilities of x are converging to x. So let's say I consider that the mean is close if the difference between your actual x bar and your given samples is like, let's say epsilon should be 0.5. So this means that your means could be 9.5 or anything less than greater than 9.5, like 9.6, 9.7, 9.8, 9.9 or 10. So this will have like 0, like yeah, 0.1, 0.2, 0.3. So yeah, this is a value. So the difference between xn minus x has to be less than epsilon to be considered converging. So in that case, the probability of this difference, the probability that the difference is greater than epsilon should be 0. And the probability that the difference is lesser than epsilon should be 1. So if either of these is satisfied, you can say that the probability of your random variables, so the probability of xn is converging. So this is basically your mu. Yeah. And similarly, you also have like something called weak law of large numbers. We saw epsilon. Epsilon is some value greater than 0. But it's a very small value. Like we saw, it could be like 0.5 or it could be 0.005. It could be any value which is greater than 0. And there's another value called delta, which is somewhere between 0 to 1. So this is much smaller. So n has to be greater than like this sigma square, your population variance divided by these two products. So if the probability that this thing, probability of your xn minus mu is lesser than epsilon, the probability of this should be higher. It should be high. So it should basically, this probability should be close to 1. Close to 1. And basically it should be greater than 1 minus whatever the delta is. So let's say delta is, again, let's say delta is also 0.5. So 1 minus 0.5 would be 0.95, right? So the probability of this has to be something greater than 0.5. So the probability should be really, really high, 0.96. It could be 0.97 or something. So yeah, I think, yeah, this is not necessary to understand for solving these week's problems. But yeah, when you think about it, you can understand what this actually means. Same thing. Same thing. Okay. Okay. I think, yeah, so that was all that was covered in the lectures. And let us now move to the problem solving session. I'm not able to change my slides. Okay. Yeah, before that. Let me just paste that formula for you. Okay, just give me a minute. I might need to take a screenshot. I don't know how to take a screenshot on this. Okay, just give me a minute. Mhm. I'm just trying to like copy the formula so that it's easier to have a look. Mm, with image. Okay, yep, I got it. Yeah, let us solve the problems. So yeah, we just had a few, like we just had 5 numerical questions. The rest were like R-based questions, and we'll look at that when we come to it. Okay. So the first question is, let X and Y have joint bivariate normal distribution with probability density function as, so the PDF is given here. So the questions are, what are the means of X and Y? So if you remember this formula, you had the formula here, and you had mu of X and mu of Y only in the numerators. You don't see these terms anywhere else. So if you try to match the formula here, you could see these 2, 4, 2 minus 4, 2 minus y minus 4. So basically your mu of x is 2, mu of y is 4. If you just match the formula. Yeah. So that answers this question. So that's it. That's quite straightforward and simple. And the next question is also very similar. They have asked the standard deviations of x and y. So standard deviations of x and y are basically sigma square x and sigma square y. So where all do you see these terms? You see sigma. Oh, standard deviation is, sorry, sigma x and sigma y. So this is what you need to find. And in your formula, you can see these values here. Sigma x is here, sigma y is here, and sigma square x is here, sigma square y. Yeah, you can see these. So we try to map these, what is given. So basically this is 9. This is 25. Again, this is also 9. And this whole term here is 15 pi. So now let's say you just apply, like the simple thing to do is just look at these. So sigma square x is 9. So sigma x would be 3. And sigma y would be 5 square is 25. So sigma y would be 5. You can also just apply these values here to cross check if you are getting the same values. So for example, let's consider this term. Oh, but you need to know rho before that. Can come to this. So we can calculate rho from this basically. Let us try to do that. So let's say now you had mu x is equal to 2, mu y is equal to 4, sigma x is equal to 3, sigma y is equal to 5. So this is what we tried to calculate based on matching these formula. And you can calculate rho also by applying these. And then you can cross check if you're getting this answers. Let me copy this again. Copy. Let's take the first part maybe first. You have 1 by 2 pi sigma x sigma y 1 minus rho square. So in your question, let's try to copy this also. Oops. So if you look at this part, this is equal to 1 by 15 pi. Now you can just apply all these values here to get the value of rho. 1 by 2 pi into, what is x? X is 2. Sigma x is 3 and sigma y is 5. 1 minus rho square is equal to 1 by 15 pi. Let's say you just cancel out these pi's in the denominators. 5 3s are 15. So you'll have 1 by 2 into 15 into square root of 1 minus rho square is equal to 1 by 15. So all these are terms. So you could cancel these two as well. So now basically you have 1 by 2 into square root of 1 minus rho square is equal to 1. So this can be 2 into 1 minus rho square is equal to 1. 1 minus rho square is equal to 1 by 2. Okay. And you can take the square on both sides. If you take square on both sides, what happens? You have 1 minus rho square is equal to 1 by 4. new slide. Okay. What did we have? 1 minus rho square is equal to 1 by 4. You can bring this side and this side. So you'll have 1 minus 1 by 4 is equal to rho square. If you solve this, you'll have 4 minus 1 divided by 4 is equal to rho square. 4 minus 1 is equal to, so rho square is basically 3 by 4. I think I'm doing something wrong. Rho square is 3 by 4. Yeah. I think I did some mistake here. Okay, wait, let's try the easier way rather than just complicating this. Copy. Yeah, I'm sorry about that. Paste. Okay, let's maybe take this. This is the easiest. So, wait, if you look at this last term, look at the last term, you have 1 by minus 1 by 2 into 1 minus rho square. No, minus into minus becomes plus. So, yeah, 2 into 1 square. 2 rho divided by sigma x, sigma y. You have these. Yeah, this whole value. No, wait, I'm doing it wrong. Yeah, should maybe let's just come back to this. Let's look at the other problems and come back to this. Just remind. No, yeah, we'll come back to this because there are 2 more questions. Okay, so this question is checking chats. Hello. Were you able to hear me all this time? Yeah, can somebody just confirm that? Because my laptop was on mute. I'm not sure if you were able to hear me. Was the audio fine? Okay, yeah, let's just move on to this question. So an experimenter is attempting to locate a target in a 3-dimensional space. And the 3 coordinate errors in meter of the point chosen are independent. So there's a point chosen randomly. Wait, what is this? An experimenter is attempting to locate a target in 3 coordinate errors of the point chosen. So yeah, this is a standard normal distribution which follows. Oh, sorry, it's not standard. So it follows a mean and a standard deviation of 3. So at this point, it follows a random, it follows a normal distribution with 0, sigma. So you need to find the probability that the distance between the point chosen and the target exceeds 4 meters. So basically, you're trying to calculate some Euclidean distance. So what is Euclidean distance? It's basically like when you have 3 points, you have x minus like whatever point that was, x, let's say this, yeah, x minus y the whole square plus y minus y the whole square plus z minus z the whole square. But yeah, let's not get into this. So here basically what they mean to say is you have 3 coordinates and they're trying to calculate the distance. So this distance, let's say given by d, it follows a chi-square distribution because so this d is based on three random variables x, y, and z. So what happens, like if you remember, we saw the summation of random variables. Like, so the summation of x minus mu by sigma the whole square, when you do this, it follows a chi-square distribution. So we know that this point D follows a chi-square distribution. And we need, how do you compute it? X minus mu is 0, sigma is 3, plus whole square. So the sum of the squares follows the chi-square distribution. So x minus 0 by 3 the whole square, y minus 0 by 3 the whole square, plus z minus 0 the whole by 3 the whole square. So this is basically d square, gives you d square. So when you simplify this, what do you get? D square is equal to x square by 9 plus y square by 9 plus z square by 9. So this is nothing but x plus y plus z, sorry, x square plus y square plus z square by 9. So what you can say about this is d square by 9 is equal to the sum of all these random variables x square plus y square plus z square. So this just follows a chi-square distribution. Now what you need to do? You need to follow. What was D in the question? The probability that the distance between the point chosen and the target exceeds 4 meters. So you need to calculate probability of D exceeding 4 meters. So you have to find probability of D greater than 4. Wait, here we have computed this separately. We have D square is equal to x square plus y square by z square divided by 9. So the question, we need to calculate probability of D greater than 4. You can also, like, we have d square, so let's compute this to d square. So probability of d square would be greater than 4 square, which is 16. And you can also have 9 in the denominator, so you could do probability of d square by 9 greater than 16 by 9. So 16 by 9 will give you some value. So basically this thing, we know that x square plus y square by z square follows chi-square distribution. That's why we divided d square by 9. So this d square by 9 will follow chi-square distribution. So you just basically need to calculate probability that chi-square 3. N here is 3. Why? Because we had 3 random variables, x, y, and z. So we have 3 degrees of freedom. So chi-square with 3 degrees of freedom greater than 16 by 9. So you need to compute the value for this. So you can do this with R. Like we'll look at that. So it's basically again something like p chi. Yeah, let's see how to do that. So yeah, to solve this question, you just need to calculate this. So the next question, the time it takes to fill a medicine bottle is normally distributed with mean 20 seconds and standard deviation 4 seconds. Mean is equal to 20 seconds. Standard deviation sigma is equal to 4 seconds. So this would is equal to. So what will this give you? The variance will be 16. So if a sample of 25 such jobs to fill a bottle is observed, what is the probability that the sample variance is s square, right? So you need to find probability that s square will exceed 15. So if you remember, we saw like a sample like s square versus population sigma square variance. So that was related by a formula given by n minus 1. S square by sigma square. So this follows a chi-square distribution with n-1 degrees of freedom. So yeah, you need to apply this here. Why? Because yeah, you are sampling 25. So here n becomes 25. So you're just sampling it and you need to find this probability. You need to find P of S square greater than 15. So you can compute it. So first you can have S square divided by sigma square, because sigma square is in the denominator. So you basically have, no wait, or you can just directly apply this n-1 S square by sigma square. What is this? No, wait, let's just go step by step. We divided by this by sigma square. So 15 by, what is sigma square? 16. 15 by 16. And now you multiply this by n-1 on both sides. So n-1 S square by sigma square greater than 15 by 16 into, what is n-1? N-1 is 25 minus 1. It is 24. So now what is 15 into 24 by 16? Wait, just complete that. 15 into 24 divided by 16. So this is 22.5. So basically probability of n-1 S square by sigma square is greater than 22.5. So now what is this? You have to do probability of chi-square. How many degrees of freedom? N-1 degrees of freedom. So 24 degrees of freedom. So you have to find the chi-square distribution where this chi-square 24 is greater than 22.5. You need to compute this. You can compute this in R. So that gives you the answer to this question. Okay, now let us go back to the question. I was having some problems calculating. Just have a look. So yeah, let's just take a look at this last term. So we have 2 rho divided by sigma x, sigma y. So this whole thing is equal to 1 by 9. So to compute rho, what do you need to do? So sigma x was 3, sigma y was 5. Divided
But
by,
ma'am, there is other constant term which is also there in the expression itself,
you mean this?
minus. Yes, yes, yes.
Oh, okay. Wait.
So
Yeah, yeah, that is fine, but let's just compute the rho term. I'm trying to calculate rho. Do we need this here? Yeah, but this is simplified to this. So basically this term here, the term outside this bracket. So this minus 1 by 2 into 1 minus rho the whole square is equal to minus 2. So wait, like the based on what I was doing, So I just looked at this term. This term here, we know it's 9, 1 by 9, and you can cross calculate this. So you'll get rho is equal to 3 3s are 9, 5 2s are. So you are getting rho is equal to 5 by 6. This is your value for rho. So now let's cross verify this. Let's see if I apply this rho is equal to 5 by 6 here. Am I getting -2? That's how we cross check. -1 by 2 into 1 minus, what is rho? 5 by 6, the whole square. I need to get -2. But yeah, right now this is unknown. So because we're checking. Mm, so yeah, we will have -1. Wait, I just need to solve this. How do I solve this? Let's take a new slide. We had -1 by 2 into 1 minus 5 by 6 the whole square. I need to compute this. So we'll have -1 by 2 into, what is 1 minus? Okay. 6 minus 5 divided by 6 the whole square is equal to 1 by 2 into 6 minus 5 is 1 by 6. I don't think I'm getting the answer. Yeah. There's one. 1 by 2 into 1 by 2. Yeah, there's something wrong, I think. This is not giving you that value.
Yes, ma'am. Ma'am, I have just watched the other TA's lecture
Yeah,
also for the
this
question,
means
but
that,
things
yeah,
is
this
not.
is, yeah, so the standard deviation is computed wrong here. So standard deviations are not 3 and 5, right? You have to
Ma'am,
like,
how to calculate the standard deviation in such situations? Like if we have not the direct terminology given to such questions.
okay, that complicates your situation, but
Because ma'am, the similar question also provided in the assignments also. So
but that also-
we are facing bit difficulty in solving such questions.
okay, wait, let us try it now. But I'm pretty sure in exam you shouldn't be given this kind of complicated ones. Like you should be able to directly make it out from this formula. So that was actually the whole point of the question. But yeah, there's probably
Ma'am,
some.
if you have a look on the assignment question, the other in this question other factors also given, so we can't able to generalize from this generalized formula.
Let me just have a look. Question number.
Question number second.
Let me just check. Oh, okay. Yeah. So the row is not given here. Like, yeah, it's directly computed. 2 sigma. So basically mu is 3. Mhm. But Let us try the way I was calculating previously. Yeah, let me just check if that is correct. Sigma is equal to 1 by 4. No, no, it's not this. No, it's the string. Mm, 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 mm. Minus. Wait, what did I do? Okay, it's equal to 10. Yeah, it's a bit complicated. I think the easiest thing you could do is, let me, how do I erase? Oh, Just copy this. This is the easiest to calculate from. No, I'm doing the same thing I can. You're having rho square is equal to 3 by 4. This is what I'm getting if I apply those. What happens if I substitute that here? I'm just seeing if I'm getting the correct answer. 2 rho. Two rho by sigma x, sigma y. It's so hard to calculate that here. Square root of 3 by 4 is Q R T R.
Ma'am, in the assignment also, in question 4, I'm not getting any of the alternative of the
Which
question.
one? 4.
Question number 4 means getting the variance value, but not the expectation value.
Oh, how did you do this? Were you able to calculate rho?
Ma'am, by comparing the first term,
Yeah.
means putting the value of standard deviation x and standard deviation y, and comparing the first terms, 1 upon 2 pi uh,
So you have to
standard deviation of x and y.
yeah, wait. You have to apply. Where is it? Yeah, you have to apply this formula, right?
Yes, yes.
Yeah, but for this you needed rho, right? Did you calculate that?
Yes, ma'am. From the first term,
Okay. This one.
what the generalized formula you just provided, in that first term, I calculated the row.
So you use this to calculate.
Yes.
Yeah,
So that's why I want to cross check. Is it the finding the row in that way? Is it correct?
yeah,
Because
that's how you find it.
all the question I am getting the solution, but except this fourth part.
Yeah,
Uh,
then that's how you calculate. That's what I'm trying to do in this case also.
okay, okay,
Like, so yeah, basically that's how you're supposed to calculate it. So yeah, if you're
okay,
getting
ma'am.
the right answer, fine. Fourth question, which part were you not getting? The mean expectation you were not.
Expectation. Yes, yes, ma'am. Expectation I'm not getting.
Okay. Yeah, I'll just make and put it on the discussion forum. Okay. Yeah, if you're getting, so are you getting answer for question 1 to 3?
Yes, ma'am.
Right.
But I'm not sure that if calculating the row in
Yeah,
by comparing the first term, is it correct or not?
that is correct. That is
Anyhow,
right.
I get this solution, but not sure
Yeah, that should be correct.
because other I just watched the lecture of other two TAs.
Mhm.
On the basis of that, I able to calculate that solution.
Okay. Yeah, that's how you should do it. If you maybe it's just probably the options are wrong. What is this giving? Yeah, I'm trying to do the same thing for this question.
Madam,
Yeah.
madam, one request. Go with the next question. We'll come back to this later. Because
Yeah,
time
so
to.
all the other questions are based on this calculation only. Like I discussed the next two questions. So those are fine. We have two more questions. And yeah, you just have to calculate expectation and variance of x given y. So that has you have to calculate using this formula here. So you have to calculate mu of y plus rho sigma x sigma y divided by x minus mu x. So yeah, for that you need to know the value of rho. That's what we are trying to calculate. But yeah, if you are able to calculate it and if you know what is you should where you have to substitute the equations, then yes, I could just discuss R. Yeah, we don't have much time either.
Go with the R commands, madam. Those,
Okay, so that will get
after that,
practice.
you can come back to this.
Yeah, you just need to know which formula you have to apply where, and you can try calculating in case. Okay, how do I? Is my screen sharing gone? Okay. When did my screen stop being shared? I don't know. Yeah, I just noticed it. Okay, anyway. So it's sharing. Where is our studio? Yeah, do you want me to go through this lectures again? This was already covered, but yeah, these were the other questions. Yeah, so these were the questions in your assignment. So you need to find the value of P of chi-square 15 lesser than or equal to 25. So here your degrees of freedom df is 15 and the value of q you have to separate. So you basically have to write this R command. P chi sq q is equal to 25, whatever value is given here, and df is your degrees of freedom 15, and lower tail is true. So whenever you see lesser than or equal to, your lower tail is the default value. So you have to just substitute this. You're getting the answer 0.9505. Yeah, so this was one of the problems. And the other problem was you have to calculate P of chi-square 15 greater than 25. So here you have to write the same thing, but lower tail is equal to false. And you get 0.04999 as the answer. And the next, yeah. Yeah. So the next question is the value of the probability of T15, T with 15 degrees of freedom lesser than 1.6. So here PT. So like P, probability of T distribution PT, Q is equal to this 1.6, comma DF is equal to 15, lower tail is equal to true because it's lesser than sign. You compute this and you get the value 0.93. And similarly, they've asked like probability of T 16 degrees of freedom greater than 1.8. So here lower tail would be false. Same command. And similarly, they've asked F distribution, the value of P of F with 8, 16 degrees of freedom. So for F distribution, you have to specify Q, which is this value, 1.3. And then DF1 is this 8. And DF2 is the second degrees of freedom, like n comma n. So it's 16 in this case, DF2. So because it's lesser than equal to, lower tail is equal to true. Substitute that, you get the answer. And similarly, the same thing again, they've given ask for greater than 1.3. So lower tail, you write false and you run and you get the answer. And now they've asked for 60th quantile of f of 8, 16 and its R command. So if you want to find the quantile, you write QF, or like if it's a T distribution, you write QT, and if it's a chi-square distribution, you write Q chi SQ. Yeah. So this is just a standard nomenclature. So QF, because the 60th quantile, you write 0.6, and DF1, DF2, and lower tail is equal to true. So 1.21. So this means that at 1.21, after that point, your area will have 60% of the whole area under the curve. So yeah, all other questions were like this. Wait, let me look at your current assignment also is very similar to that. You basically just have to run with R. You just have to know which one to apply where. So what you have to look at is you have to see what distribution is, what they've asked, and this value here. And the main thing is you have to look at whether it's greater than or equal to or lesser than or equal to. That's the only thing you need to remember because you specify this lower tail accordingly. Otherwise, all these will be the same standard formula. Yeah, is that fine? Do you want me to go through these everything as well?
No, madam.
Okay.
Next problems. After this R commands, there are some other problems. 15 and 15 also is there.
Yeah, so that's all for that week's lecture. It's just we have to go back to that problem we're trying to solve. So there was just 14 questions. Yeah, so there were like 5 of the numericals and 1, 2, 3, 5, 6, like, yeah, 1, 2, 3. Yeah, there were like 8 such problems. So these are all the problems that I had. Yeah, I could just go back to discussing this. I am not sure how to do that. Okay, wait. Let me reshare my screen. Oh, here I was getting. So yeah, in this question, you're supposed to get rho is equal to 5 by 6. But yeah, it doesn't satisfy this part though. But yeah, in the given solutions that were given to us, it said sigma x and sigma y was 3 and 5, and rho is 5 by 6. Just go back to that. But it looks wrong because when you substitute that here, you need to get 2, but you're not getting that. Okay, let me just check this. Have anybody else tried the assignment questions for this? Question number 1, 2, and 3. Minus. I think the easiest way to find rho is to just substitute the first term. Because, yeah, all these would be counted. But either way, I'm not getting the answer. Have any of you else tried this problem? Like,
Ma'am, we have to multiply. Sorry, 1 minute. The screen.
well, do you wanna look at this? Yeah.
Yes. Ma'am, here we have to first equation is correct. That is 1 by 2 pi into sigma x sigma y into square root of 1 minus rho square is equal to 1 by 15 pi. That is okay. But next we have to multiply, that is we have to equate the term like 1 by 2 into 1 minus rho square into sigma x square. That should be equated to minus 2 by 9. That is without minus 2 by 9.
Yeah, you
1 by
mean
2 into
multiplied by
this into sigma x square, the denominator. Sigma x square also with the first term. That is 1 by 2 into 1 minus rho the whole square into sigma x square is equal to 2 by 9. Similarly, 1 by 2 into 1 minus rho the whole square into sigma y square is equal to 2 by 25. And that way we have to equate.
But why are we multiplying this here? You said sigma x square, right?
Into sigma x square is equal to 2 by 9.
But why?
Here 2 is commonly taken outside. Now that also should be multiplied. 2,
Oh,
2
you're
by
talking about this.
9.
Okay, yeah,
Yeah. Similarly, in the next term also
try that.
2 by 25. Likewise.
This 1 by 2 into 1 minus rho the whole square into this should give us minus 2 by 9. So this should give us minus 2 by 9. Minus minus get cancelled either way. This 2 also will get cancelled. No, yeah, sorry, I'm
Then
doing it wrong.
here instead of 1 minus rho the whole square, we can substitute from the first equation.
1 minus rho
First
the whole.
in the
What is the first equation? Let's
we have
just.
equated it to 15 pi now that.
But how can I do that? But yeah, this is like square root of 1 minus rho square. But this is 1 minus rho the whole square. But yeah, wait, let's just try this one. Sigma x square was 9. Four. 1 by 1 minus rho square is equal to 4. Yeah, I did this. I tried the same thing. So either way, what is happening is we are getting rho square is equal to 3 by 4. So rho is square root of 3 by 4. This is what we are getting, like if we substitute this. But what happens is, if I substitute this into the equation, I was not getting this value. So basically, you're getting rho is equal to square root of 3 by 4, right? So if you substitute that here, you need to get 1 by this pi. Wait. 2 pi 3 into 5 into square root of 1 minus rho square was what? Rho square was, I lost it. Rho square was basically 3 by 4. Minus 3 by 4. This value, this whole term is giving you 0.5, which is 1 by 2. So 1 by 2 pi into 3 into 5 into 1 by 2. This gets cancelled. Oh, you're getting 15 pi. Yeah, you're getting this final answer. So yeah, basically you're so yeah, let's just make a clean slide. Yeah, it's just probably the question that was given to us was wrong. Like the solution that was given to us was wrong. Okay, I'm making a new slide. Or if everybody understood, it's fine. So what I basically did was I just used this first term, equated this here to calculate rho. And one more thing I tried was I used this term to get this term. Like I equated these two. So either way, what I'm getting is I'm getting rho square is equal to 3 by 4. Or rho is equal to square root of 3 by 4. So this is what I'm getting. So yeah, you can go ahead with this answer. So whatever you get, you can just go ahead with that. So why I kept trying was the answer that was given to us was rho is equal to 5 by 6. But we are not getting that. So either way, like whatever way I substitute the answers, I'm getting rho is equal to 3 by 4. Rho square is equal to 3 by 4. So let's just move ahead with this value. Okay, let's move on to the next question. We have this, the same joint for normal distribution function. We need to calculate expectation of x given y and variance of x given y. So the parameters we have is mu x is 2, mu y is equal to 4, sigma x is equal to 3, sigma y is equal to 5, rho is equal to 3 by square root of 3 by 4. So if you want to calculate expectation of y, you need to substitute this.
Excuse me, madam. Excuse me,
One,
madam.
yes, yes.
Hello,
Yeah.
madam. How did you get the row value there in the
Uh,
previous slide?
I can do it again. Okay. So you look at this one term. Let's just look at this first term here, right?
Okay.
Look at this first term. So you can equate it to 1 by 15. But wait, let's go do it the easier way. So what you can do is, which term has rho? This term has rho. This term also has rho. So you can do anything you want. You can either look at this term. So let's compare these two terms here. So we have this. So this should be equal to this. No, let's not take this. That's harder. Okay, let's just stick to the first term. 1 by 15 pi. We have this formula. We have 1 by 15 pi is equal to 1 by 2 pi sigma x sigma y 1 minus rho. No, wait, square root of 1 minus rho square. We have this formula, right? We know sigma x, sigma y is 3 by, sigma x is 3, sigma y is 5. So 1 by 2 pi, 3, 5, 1 square root of 1 minus rho square. So this is equal to 15 pi. Both sides denominator, we have pi, so we can cancel it out. And 3 into 5 is 15. This side also we have 15. So you can cancel these two out. Now what are you left with? You have 1 by square root of 1 minus rho square is equal to 1.
Okay.
Oh, wait, am I doing something wrong again? I think oh, we still have this 2 here. So we have 2, yeah, so we have 1 by 2 into square root of 1 minus rho square is equal to 1. Because this whole term is all cancelled out, we have 1 this side. Now what happens is, you just bring this to the numerator. 2 into square root of 1 minus rho square is equal to 1. So square root of 1 minus rho square is equal to 1 by 2. And how can you remove the square root? You can remove the square root by taking a square on both sides. Take square both sides. What happens? You get 1 minus rho square is equal to 1 by 2 square is 1 by 4.
Okay.
Okay, now you bring this side. What happens when you bring 1 by 4 side? It becomes 1 minus 1 by 4. And when you bring minus rho square to the other side of the equal sign, it becomes rho square. Now you just have to solve this. So how do you solve 1 minus 1 by 4? 4 minus 1 divided by 4 is equal to rho square. So 4 minus 1 is 3 by 4. So rho square, you get 3 by 4. Rho is square root of 3 by 4. So this is how solve rho. So yeah, the easiest way is to compare. You forget about this exponent term. You take this first part and take this first part. Just apply your standard deviation of that value and you calculate for rho. You'll get some answer. That is your rho. So rho has to be anything between -1 to +1. It can't exceed 1. It can't be below -1. Wait just a minute. So square root of 3 by 4 gives you 0.8. So we just calculated rho square is equal to this. So rho is equal to 0.8. 0.866 something. Okay. So now that's how, yeah, we have all these values. Okay, let's go back to the question we were trying to solve. Okay, so we have all these, right? We calculated all these. Now you need to calculate this expectation and variance. So for that, we already saw the formula. We have the expectation of x given y. So basically, actually f of x given y follows a normal distribution. Mu x plus rho sigma x by sigma y minus mu y, comma, sigma square x, 1 minus rho square. So your E of x given y is this first term. And your variance x given y is second term. So yeah, you just have to substitute all these values in this equation. So E of x given y would be mu x is 2 plus rho is square root of 3 by 4 into 3 by 5 into y minus mu y is 4. So you'll get this equation in terms of y. So yeah, this is your expectation of x comma x given y. You can further simplify it if you want, but yeah, you would have some options to your question. You just choose whatever equates to that. And now variance of x given y would be equal to sigma square x 1 minus rho square. So this is equal to sigma square x would be 9. 9 into 1 minus rho square is 3 by 4. So what is this? 4 minus 3 is 1 by 4. So you'll get 9 by 4. So variance of x given y is 9 by 4. Okay, like similarly, we go to this next question. The same thing. So instead of x given y, you have y given x. You just interchange it. So instead of mu x here, you'll have mu y and so on. Let us check it out.
Madam, please solve that one also.
Yeah, I'm just looking at the formula. So E of y given x would be mu y plus rho of sigma y by sigma x minus mu x. So here we have all these values. Mu y was 4. 4 plus square root of 3 by 4 into 5 by 3 x minus 2. So if you substitute all the values. Yeah, so you just have to solve this. You get the answer in terms of x. And then variance of y given x is equal to, just write the formula. Sigma square y into 1 minus rho square. So sigma square y is 25 into 1 minus 3 by 4. So 25 by 4 is your variance. Yep. Yeah, so that's it. This solves your answers.
Madam, what about the second one, madam? Standard deviations.
Oh, that we saw already. You just have to like compare the formula. Look at the what is the second
Second
one?
one.
Yeah. Just compare this formula. So you have these terms. So
Okay.
sigma square x is equal to 9. So sigma x would be 3. Yeah, so this is your standard deviation of x. Similarly, sigma square y is 25. So sigma y is equal to 5. Yeah, that's it. Yep. Yeah, that answers the problem.
Madam, the last one in the 14th question, 15th question, that lambda in the assignment it is given, madam.
Oh, that is, I think, from the previous week's questions.
Yeah, yeah.
Yeah, if you just go
But the
back to
options are also incorrect, I think so.
you just have to, if I remember, you have to apply, like, what is the question? 1 log
15th
swim
question, madam. 15th
exceeding 2
question.
minutes. Yeah, exceeding 2 minutes. So you'll have to find probability of x greater than 2. You have to integrate 2 to infinity and exponential, like n. So lambda's 1. So lambda e power minus lambda
X.
x. Yeah, you just have to integrate that.
What is the problem, madam? What is it? Poisson distribution or something?
It's just an exponential. And no, sorry, Poisson distribution. No, sorry, it is exponential distribution. Yeah,
What
so
is
it's
it?
given the question, right? It follows and yeah, it's given the question that it follows an exponential distribution. So basically, you just have to apply like, or you could also compute with R, like Px q is equal to 2, rate. So lambda would be rate. Rate is equal to 1. And because there's a greater than sign, you have to apply lower tail is equal to false.
What is the formula, madam? R command what?
Px.
Px. Okay.
Yeah.
Px of, sorry.
If you look at the standard, what is that? The standard nomenclature, you would know. So it's something like Px q, whatever value was given, then rate is basically a lambda, and then lower dot tail. In this case, because they've given greater than, you have to write lower tail is equal to false. So yeah, you just have to substitute these. So yeah, basically here q is 2 because they've asked. So that's it. That's today's lecture. Yeah, if there is any problem with the assignment, yeah, we can discuss it in the next class. I can also clarify all this about the row and all that. Yeah, is that fine? Does anybody have questions?
Oh, madam, thank you.
Okay. Thank you.
Madam, one more thing, madam.
Yeah.
Hello.
Yeah.
This video will be like recorded video will be available by morning. No?
Yeah, same tomorrow when you wake up like 8 o'clock, you should find it.
Thank you, madam.
Thank you.